Now we are in the topic 4. We are in the topic 4. So types of vectors. Already we discussed four vectors, four types of vectors. First one is a zero vector, and then unit vector, and co-initial vector, and then collinear vector. Yeah, four types of vectors we discussed, and now we are going to see the fifth, sixth, and seventh, eighth types of vectors. So once just we recap, the first vector is a zero vector. So there is no magnitude, means like zero magnitude and no specific direction. It's called a zero vector. And then unit vector is magnitude will be 1 unit, and then in a particular direction. Suppose if direction A, so A cap is a unit vector. That's the unit vector of it. The second point, types of vector. And then third one is it's a co-initial vectors. So from one particular point, to one or two vectors passing through it. So this two or more vectors. So it is called a co-initial vector. Okay. And the next one is a collinear vectors. Collinear vectors means vectors which is on a line, vectors on a line, or it is in a parallel line, like line of parallel lines. Okay, so parallel line of vectors. So this is called collinear vectors. Now we are into a fifth one, that is the equal vectors. So equal vectors are two or more vectors with the same magnitude and the direction. Same direction and the same magnitude. Same direction, the same magnitude. So we call it as the equal vectors. Okay. So negative vectors. Negative vectors are vectors with the same magnitude but directions are different. Okay. But the directions are different. That of the given vector. So directions are different but the magnitude will be the same. So those are called negative vectors to each other. Then like vectors. Like vectors are two or more vectors with same direction. Okay, it's the same direction. If you see only the direction is the same, then those are called like vectors. Unlike vectors those are not in it. Those are different direction. Okay, so it's not depend on the magnitude. So these are called like vectors and unlike vectors, and then equal vectors and the negative vectors. Okay, so we'll see some more points in this. So here we continue with the components of vectors. Actually, what will be the components in this? The components are scalars and the vectors. Scalars are like x, y, z. It's a number. Okay, constant numbers, and then x, I, y, j, and zk are the vectors. Okay, suppose like I think you all know x-axis and the y-axis, and then z-axis here. So generally we know the graph x and y. So if I extend the z-axis, so any corner you can concentrate, any in a wall corner. So you can see three lines. Okay, base, two lines, and the height. So like that only this is the corner if you imagine. Then any point in a particular distance. So that is like x point. Okay, then y point, y comma z. These are the points where the particular point you are specifically fixing. Okay, so till now we have discussed a magnitude. So what is the meaning of magnitude? So magnitude, or we can call it as a modulus of vectors. So for a point x comma y of 3D coordination, 3D system. So this is a 3-dimension objects. So 3D graph. Okay. So OP or like we can mention it as R. So is a position vector. This is a position vector with the origin. From the origin it is. Okay. So if I write it anything from here to here, this is not from the origin, right? But now this is we are calculating it as from the origin as the initial point. O is what? An initial point. And the magnitude of OP. So from this to this, the magnitude of OP will becomes OP we will write it as like this: the modulus of OP is equals to square root of x square plus y square plus z square. This is the magnitude or modulus of a vector. Okay, so we'll do some problems based on this. It's a simple question here to understand more about the magnitude. So let A is equals to 212I plus Nj. So they didn't give, like we have only Ij and Z, it may be a 0. Then magnitude of A is what? 13. They only gave us 13 and find the value of N. This value they are asking us. Just simply apply the formula here. So what is the x here? 12. Then y is 1 and the z is a 0. So if you apply it, so magnitude of this is answer, they already told it's a 13, is equals to square root of 12 square plus n square. Then the square root, if you send here, it will become a square. So 13 square is 169 is equals to 144 plus n square. So if you send it, 169 minus 144 is equals to n square. So n square is equals to 25. So n is equals to how much? 5 it is. Okay. So that's it. Magnitude, I guess we got some idea. And we'll do another problem. So another question here. So find the value of P for which the vector of this is 3 units length. Okay. 3 units length they were saying. So magnitude is 3. So that we are going to apply here. And they are asking the value of P. Then, so what I can write it? 3 is equals to, or else first square root of 2p square plus minus is however minus p square plus 2p square is equals to 3 units, right? So if I send that side, it is a 4p square plus p square plus p square, 4p square is equals to 3 square. So this all becomes 9. 9p square is equals to 9. So p square is equals to 9 by 9. If you cancel it, p square is equals to 1, p is equals to plus or minus 1. That's it, your answers. Okay. So unit length, do you understood what is the magnitude? If they give, so you should able to find like this. Okay.